Holding you from the raffle ticket prizes and going home. So you got to spend the time somewhere. But you know, thanks for being in this room, because I think it's DMR and the other one. Who here has heard of AREDN? Okay. So we may be repeating stuff, maybe not. So I'm Kevin, W4KIB. I am with GARS as well as Gwinnett ARES. I've been owning the hobby for almost 2 years, and I've been dabbling with AREDN for probably the last 7 or 8 months. So, and kind of gone down the deep rabbit hole. If you see some of the stuff that's up here. If you have a question, please raise your hand. Stop me. I'll do my best to repeat it. Someone yell if not. I've been in this room all day running AV, so my brain is trying to switch out of that mode. But we'll get rolling. Really, we're going to talk a little bit about the overview of what AREDN is. We're going to talk about how infrastructure versus the actual applications of it. Both are important. Really, the application aspect is more important, because knowing what you're going to do with AREDN is much more important than just building the stuff. And then we'll get a little bit into kind of where we are within Gwinnett, how we're building out our AREDN deployment, and what we're thinking about, and then we'll leave you with some how to get started stuff. Going through this, so AREDN stands for the Amateur Radio Emergency Data Network. It is designed, it was rooted in, emergency communications, EMCOM, but it's obviously available for anyone to use with any ham. I actually, as someone who's studying for the extra, I saw the little mesh. Hey, well, you're allowed to use mesh shows up in there, and I'm like, oh, I've been dabbling with this for several months now. I'm like, oh no, I knew that was available. But what a mesh is it takes separate nodes and builds a network based upon them. There's a lot of, and what AREDN does really great is it takes care of all the routing logic, the hard stuff that is DNS, DCP, DHCP leases, all that brilliant stuff is already taken care of for you. I have spent most of my career as a system administrator running cloud platforms. I like to call myself a digital plumber, so this kind of fits into what I do. And basically lets us build a network that we don't have to rely on the public internet. We can, using some infrastructure, but we can actually use direct RF communication. We'll show a few devices today. All these items are built off of Part 15, so they're consumer items. They have lovely AREDN stickers on them, but they are actual, you can go buy them from Micro Center if you want, but we leverage custom firmware and then use our Part 97 privileges. Where does it fit in? I'm not here to take away any of your tools today. If you're a fan of FLDigi or any of the other tools, those are WinLink, anything else, those are all still extremely valuable tools in our toolbox. I'm just gonna look here to help add another one. We'll talk a little bit about this, but what people are used to using is not radio, in this room, we're all used to using, HF radios or stuff like that. You talk to a served agency, they're talking about phones, they're talking about cameras, they're talking about computers. That's where they live. And how do we go in and play hybrid within that environment? How do we bring the assets and the speed of digital equipment into emergency communications? I stole this was a slide I think that was done to the Knoxville group. I stole it a little bit, reframed it. But as we move forward, digital communications is extremely important. And we start looking at speed, of how fast you can get data and communicate and get information down the line. And I have recently become, I loved Vara because it was easy to get set up. Larry has kind of converted me to getting really good in Packet. I understand the value of it and how it works. But we look at the speed capabilities of getting messages down the air, down the wire. Nothing really compares to when you start getting into Wi-Fi and Ethernet. And the ability to have those connections are so much faster to get data down the line. And ultimately, it's how do we get and communicate as communicators. So infrastructure versus applications. I lost a little tagline here. I was saying this is less build it and they will come, and it is more of what is our mission and capability that we need to deliver. And so what I'm gonna start off with is talking really about what tools can we deploy to actually be used. Like I said earlier, and I changed this so it'd be more visible. It was a background, but I wanted to make it easier for y'all to see. Phones, computers, video, that's what most people are used to. Like if you talk to someone day in, day out, they know how to use those kind of equipment. So breaking down into a couple different things. Communication, voice over IP. What this allows us to do is literally pick up a phone, and talk to anyone else on the mesh. We can do it directly via the IP address, or we can use PBXs, public branching exchanges, to actually have extensions. And there's something called Mesh Phone. We actually have in the room is Mark, who into MH, does a lot with that. We've got some PBX stuff here as well, but how do you connect these different things together to talk to different systems? People know how to pick up a phone and dial an extension. Some good brands to look into. I know Larry's on the table is some of the Grandstream stuff. There's Yealink that's good. Cisco's good as well. Don't fall into the pitfall that I ran into, is if you get a Cisco phone, some of them are locked into the Cisco call manager system, that they will only talk to the Cisco appliance, and you can't do anything with them. They're really cheap on eBay for that price, but you can't get past them. An example here is one of the Go boxes. It's been on display, I think, all day today, basically to be able to set up a PBX with battery and everything else running in there. We also have a couple text-based chat programs. We talked a little bit about, in Georgia, we're big D-Star, so you talk about DRATs. Very valid tool, for, again, another tool in the toolbox. We can add in other items. So there's mesh chat that's available. This is specifically designed to work in AREDN and is decentralized, so each node can keep and send messages without having that traditional client-server relationship. But we can also, because it's a standard TCP IP stack, we can run client-server items like there's Mattermost, which is similar to Slack, or Discord is a little heavy. And then we'll talk a little bit about this also, but there's a tool chain called Nextcloud. There's a chat or talk function built into that. And we'll talk a little bit about file sharing in a minute. Again, anytime you're in that server client, now you're needing more robust connections because you have a single point of failure. The client or the server goes down, no one can talk to it. So you need high availability in that case. You can also run traditional email programs over it, but you can also have WinLink. You can use it, because a lot of us are familiar with WinLink today. On the mesh, you can run it in post office box mode, so you can actually post mail and retrieve it from a known node, or you can do peer-to-peer, or you can just run WinLink in its standard component and just use AREDN as the internet source of it. And then I do that so that if I ever need to manage anything, I can go over the mesh, over VNC, and make sure my node is actually working. I kind of branch these off. Instead of doing communication, we talk a little bit like, how do we share knowledge? That's the next thing is not just situational awareness information. I talked a little bit about Nextcloud, so file sharing. This allows you to actually have a self-contained, think private G-Cloud or O365 instance on the mesh. We've used this in a couple different ways. What the big one is, it collaboratively lets you edit files and have a central point of, it's actually deployable. So like we've taken it portable, we've set it in the field, and we've used it as a backup when we're doing multiple operators and to share that workload. So we've had one person who is just the radio operator, who's just in charge of getting communications from ICS forms from WinLink, and then dropping those in to be parsed and sent somewhere else. So, and we did this on our simulated emergency test. We were using that to actually move forms, and there was someone who was handling that data and then logging into WebEOC or who could process that. What that let us happen is we actually had a radio failure during the middle of it, and so seamlessly we could just move over to another operator, and they didn't have to grab all those files. They had the entire list of everything that was happening during that item. But you can also store your standard, your ops plans, any of that can be stored there and viewed without any internet or available for anyone on the mesh. Again, in the vein of knowledge sharing, and we'll get to the hardware and the fun stuff here in a little bit, but kind of what to kind of work towards. CCTVs, so PoE cameras, these really allow you to, you hear the phrase, a picture is worth 1,000 words. So how can, versus you being able to actually have to communicate it, if someone can just see what's going on, they have a much better situational awareness of what is happening. So we've seen these, we are looking at them for a particular event. We'll kind of push that down later on, we'll talk about that. But it allows, again, to remove that operator a little bit out of it and give someone like a served agency to have a more native experience that they're used to working in. And how many here for agencies have felt, or for, a volunteer crunch? How many people don't feel like they're getting a lot of people signing up for stuff to help out? How do you become how do you use technology to be a force multiplier? As that's where some of this stuff comes in, is how do we, that's a problem. And it's not just in ham radio, it's not amateur, it's in every particular nonprofit or volunteer organization is feeling that. On top of this, there are some open source network video recorders. So instead of just looking at one camera, we can pipe in a bunch of cameras and actually use some of that. Frigate's one of it. I've used it a little bit. It's a little heavy for the mesh. I would use it with caution. Again, this is where we're talking about, here's your applications. What do you need to build into your mesh to take care of that application? So here's the fun stuff. Now we know what we want to build, what we want to do. What do we need to use? We've got a few things here to look at and kind of talk through. So there's basically 3 sections in how do we get stuff as we look at our networks. You've got your local or your last mile delivery. Think of your Amazon delivery guy or drivers, your UPS people. It's getting that stuff to the actual computers that you're going to be using. So we run into stuff like these, which is the small router. This is an AC Lite. It's the US version. If you're used to the white version, I've got one in here. But this is what allows our computers to connect to the mesh. So either via Ethernet, or there is 2 Wi-Fi radios, or 2.4 and 5 gigahertz in here, so that your computer can actually connect and get an IP address on the mesh network. There are smaller devices, like the GLNet devices. Mark was kind enough to actually show there's an Unobtainium one. This is no longer made. This is I think it's the AR150, if I remember it's the GL150. It's the 150, I remember the model number. But basically plug it into your computer, and now this USB stick gets you on the mesh. What these do is get that last mile connectivity for your house or your station to connect. We'll get into more of what that Go box is here in a minute. The next thing comes into how do you connect to the broader mesh? So it's great that this is sitting on your bench next to your computer. How are you going to talk to the rest of the mesh? You need 2 things. You either need to have a direct RF link. This isn't going to reach very far, so we start looking into things like segment antennas or highly directional dishes as what we call DTD, or device-to-device connectivity. They allow this node to connect to here and connect out further on. Or we do something called tunneling, which is very similar to a VPN. As we go up, we start looking at the relay, or that middle mile. These are how do we get, think 3 to 10 miles is what's recommended in this case. It's really depending on terrain. We'll talk a little bit about it later. But this is how we start filling in and connecting different operators together. If you think of think of like a digipeater or a fill-in digipeater, where you're like, hey, I need to get a small message to a much more powerful source further downrange. These are more directional antennas and ultimately connect to the backbone, is ideally what we'd like to have. And this is what kind of bridges between your local network and the backbone, and ultimately increase footprint. So we got a couple here, again, highly directional dishes, less directional 128-degree antennas that give range, that are other valid options to use here. And then finally, I wish I had this was my picture. This is not of any of our setups. Is you get into the backbones, and these are your very, very directional point-to-point, long-haul connectivity to connect the broader not to the broader mesh, but to get connectivity across an entire county or an entire over a region. And so what this does is these are usually using you're pretty much exclusively using dishes, and then you may be able to provide local coverage if someone's nearby, but you're really that point to point, and then you're getting down to the relays, down to the operators. And that's really how we get into the 3 tiers of the topology of AREDN. I'm hoping I'm not, let me know if I'm going too fast. I tend to speed up when I'm on stage, so please tell me to slow down. So what are we doing in Gwinnett County? What are we looking at doing? And where are we? So I would say we're on the ground floor. We're getting groundswell. There's a lot of proof of concept work. We're doing a lot of education on capabilities, like today at TechFest. We've done it at different presentations. What can you use this for? How do you get started? How do you actually build these or flash the firmware on these things? And how do you start looking at how we're going to use them? We've done a lot of learning and prototyping. So we've done some setups to see like, hey, what if we did this and what's bad? Like we learned like, hey, don't put 4 or 5 of these in the same hangar and turn them on full power, because it's not a good idea from a demonstration perspective. So like, lesson learned, but it was like, hey, that's okay, that's overkill, dial them back, things like that of multipathing. And you literally, the noise was just too much, that it was actually kicking into the microphones. So we're learning a lot of that. And we're starting to going through kind of what the planning could be. So we're not ready for channels or separating our channels or SSIDs right now. Something long-term we may consider. And we've started looking at like, where do we want to connect? What are our backbone sites? Where would relays need to go? How do we connect? The challenges. As we all know, anything up in the ranges that these operate at, 2.4 and 5 gigahertz, are line of sight systems. This is a large, actually the colors kind of bleed through here, but if you notice in the general Gwinnett area, there is not a general high point, like a mountain, that's available to us. We have a lot of generally flat, rolling terrain, which means we have lots of dips and lots of little high points and things like that that cause challenges for us. So getting a site that we can all beam towards, not usually available. And for the few of us that are running local, a couple of us are in dips, and so we love to say like trying to get a snorkel out above on a tower or somewhere to get some signal is what we have to do. And so what this has kind of gone through is like, how do we go through and define what are the critical links between sites, and then also for operators who are key to running the connectivity to the broader mesh. So who's hosting the different tunnels that are available, or where people connect to? What are the RF links that are available, so that we can stop relying on tunnels, which is what we are heavily reliant on right now. I don't think we have any direct RF links last time I looked at the map in Gwinnett County. So what are we planning? Well, like I said, we're learning, we're doing a lot of proof of concept stuff. A lot of our things we're looking at is from a portable operation perspective. So how can we take and work with served agencies to actually provide additional capabilities and services? So a couple things that are out there. GARS does provide support for the Memorial Day Parade in Decula. And so how can we provide additional camera support to actually, so that the parade director can see like, hey, when is the parade done leaving? Have they left? How fast are they moving? Have they made it to the high school yet? Are they making the turn over here? That kind of level of communication, so they have an understanding of what the parade is doing without relying on having multiple operators in those locations. We still will, but again, talking about less volunteers, how do we fill in that gap with technology? We're also looking at, do we put in voice? Do we put in VoIP to allow them to, instead of having to have a radio operator stationed next to them to relay traffic, that they can pick up a phone, call the rally point where we're stationed with repeaters and or stationed with operators, and they can ask for information. Again, things we're looking at. Coming up in March, we also we work with the Northwest District to support a couple ultra marathons. So coming up in March is the Georgia Death Race. It's in the North Georgia Mountains. We are the point of communication for all of them. And so we're not looking to say, hey, replace WinLink or replace traffic, anything like that, but how can we better support our aid stations that are there and then maybe connect back to other stations to share information. It's about 300 or 400 runners over a 24-hour time span. Other ones we do run over a 36-hour time span. How do we make sure we don't lose a runner? It's required on a human, if someone passes through and we're like, oh crap, did I get that number that ran through? And so we're looking at, do we use cameras as an option to support that so we can go back, pull that footage, and then leverage having AREDN available to us to provide either race status back to race control or to even our local aid stations. They don't have to come over and ask, hey, what about number 310? What about number 201? Have you seen them? Where are they? And literally we'll spend multiple times an operation for 10, 15 minutes going through and asking us, and that takes an operator off the air, or they're now listening to do things. And so if they need, if there's a call that comes in, that is now, their brain is not, they may miss that. And so how do we let them have that data without us actually having to be involved in the loop? And again, we talked a little bit Nextcloud, balancing that workload. If you're the radio operator, you've got 2 VHF radios, you're handling WinLink traffic and voice traffic, and someone's yelling at you that I've got 4 or 5 runners coming in at a time, and you're trying to do both and listen to the radios. I've done it. It's a little scattershot, and it's like, how do we split that and move it over to do better workloads? And so this is really what we're looking at of like, as we prove this out, demonstrate some stuff, grow in a way that's actually sustainable. There's no reason for us to go build all this infrastructure and no one wants to use it, or we don't know how to use it. So we're going slow, seeing what we can learn, and go from there. So what you all came here to learn is, how do I actually use this, or how do I get started? My first hardware setup. So we kind of really will talk about, most people start with an AC light. This is the US version. The international version is the white version. It's also in this box right here. It is the OG workhorse of a lot of, when people say, hey, I'm getting started in AREDN, you grab that. Because what you have is you have the ability to have Wi-Fi, it can connect to a mesh, you've got Ethernet. It's kind of a good to go connectivity. I would say the AC light is starting to show its age and long in the tooth. The ports are only 100 meg speed. It's a single core machine. So it's definitely starting to show age, still valid. I build them in all my Go boxes because you can find them dirt cheap now. But if I was to say, hey, you're buying hardware, look for a good deal on an AC2. The AC2s are quad core. They're gigabit switch ports. They look exactly like the AC lights, so you have to be. They are configurable. They give you more. You can run a multiple DTD ports on it. We have some designs for that, but they're just more future-proof. So that's kind of where you get started. If you don't already have one, I would highly recommend picking up an unmanaged switch, a 5-port switch. If you got a switch available, that's great. It's not for AREDN, it is for flashing. It makes it so much easier to flash your equipment if you have a switch. I put one on here, it's about 15 bucks on Amazon. It's just one of those nice things to have, and it also, if you do have one of these and you need more ports, you can now expand. I do that in the setup at home, where I have one of those running and I have a couple AC2s and all sorts of stuff. And ultimately, you're gonna need a computer to flash. So these come shipped with, MikroTik hardware, TP-Link's firmware, and MikroTik's firmware. We need to flash on it OpenWRT that has been, some additional stuff added for AREDN. And so you're gonna use the AREDN firmware to flash on these that installs OpenWRT under the hood. and a few other customizations that make it AREDN. You can go back, so it's actually pretty easy to go. I've downgraded and gone back to it if you need to, but I don't know why you would. I could sit here and walk you through how to flash stuff. I would highly recommend AREDNmesh.org is the go-to site. It is where all the documentation is. It is the supported devices. So before you go find a great deal on eBay and go grab a device, check and see if it's actually supported, if it's not been sunsetted. There is a MikroTik AX. It is not supported. Don't confuse yourself with that. We had someone who did that. It may work eventually, but we don't know. It's not supported today. The current software is available there. You can run the stable version. I'm running nightlies, which have been working great, but again, mileage vary. I wouldn't, unless you need this functionality that's there, I would run the stable version. There's a couple different YouTube videos I linked here. I'm still editing the one from the GARS, a simple presentation we did at GARS, where we talked about it. That'll be available eventually on our YouTube channel. But the documentation that's available on the AREDN site is kind of the go-to. And then really okay, now I've got the hardware. What do I do? You want to flash it and configure it. Follow the configuration steps. They're very easy, but they also can be kind of tricky, especially the two reboots after it's the two reboots after configuration. Don't freak out. It is planned. It'll tell you that, but just be patient. Especially if you have an AC light, be patient. If you have RF available in your area, great. Please let me know where that is. You will need a more directional node. This is not gonna reach very far. It would work great in here. It'll work great out in the main hall. This is not gonna go long range. You're going to need a directional antenna. So you need something like this, or even the dish. These are the TP-Link 510s. It's 5 gigahertz. They're $60 at Micro Center if you want to know where to get them local. How do you figure out who you can connect to? I'm going to point you to the AREDN mesh map that's available on the AREDN website. Figure out who they are. What is the current, if you don't have an organization that's kind of structuring stuff, that are more mature, that publish out, hey, here's the channel and the SSID we're using and everything else, find that local operator to get that configuration from, or reach out to your local club. If you don't have mesh, which for all of us in Gwinnett County is currently the way it is, hopefully eventually that will change, you're gonna need a tunnel. Some of us who have been on it longer are maxed out on tunnel space. So again, look around on the map, see who's local, and see if they have ability to host you, or if there's another club or a ARES organization that's available to run that information. I can't stop, and I have to say this at the very end. Gotchas here, and friendly reminders. So if we're using the Part 90, if you're going over the air and you're using your Part 97 privileges, that means the message has to go in the clear and cannot be encrypted. So that means no SSL, that means no TLS, that means no HTTPS if you're going over the air. If you're going over the tunnel, that's fine. That's the internet. That's not traversing the RF. There are thoughts around administration on whether you can SSH. Use it at your own risk. But I have to put that caveat in there because I don't want anyone to get that. There are worse things you can do. The FCC is not going to come banging on your door because you probably sent an HTTPS message. I just have to say it just as a cautionary tale. There are ways of actually setting it in the firmware to say don't allow encryption. You can turn that on. It's part of our understanding of when to turn that on and when not to. For all the services I install them also with the HTTP ports enabled, and that's just what I use when I publish stuff. I'm going to pause. That's all I have. Questions, thoughts, concerns? Yes. Ubiquity equipment is great. I would say Ubiquity, so the question was, what about Ubiquity equipment compared to TP-Link or MikroTik or GLNet. What I would say is watch your versions. There is more sunsetted hardware in Ubiquiti just because of memory. So just keep an eye on that. If you can find it cheap, especially right now as we start seeing people roll off Wi-Fi 5 and even Wi-Fi 7, Wi-Fi 6 is out available now. Wi-Fi 7 is coming into place. So you're going to see enterprises start pulling hardware. If it's available in the sunsetted list, it's probably going to be, or not sunsetted, in the available approved list. You might find it cheap as these enterprises start pulling that hardware out. The TP links, I like this because it's close. I can get it. B&H Photo also in New York will often get these at a good, like at $10 cheaper than Micro Center. So you can get that, or it's a good place to get Ubiquiti gear. It all works. Once it's flashed with the AREDN firmware, it works the same as whether it's any of the other vendors. Yeah, so the only thing like this in the Ubiquiti line, this would be the nano stations. There are certain nano stations that are sunsetted and certain ones that are available. That Ubiquiti does not do a wonderful job, or when resellers sell them, of telling you, is it an AW or an AX or things like that. So that's just a gotcha. So if you are looking at used gear, ask them like, hey, can you tell me what the number is under the hood? But used gear is great. I didn't show this. So this is also this is one of our kind of AREDN Go box, or one of my AREDN Go boxes. It has an AC light in here as well as the up converters. So this will let me run this sector antenna and either a camera or a PoE phone off of this box, and just plugging in a battery, and we're ready to rock and roll. And it's just available on the mesh. I was seeing I was seeing if I could hit anything. So this is the AREDN UI. I just went into mesh status to see who I could talk to. Obviously, I'm seeing Mark's stuff up front, but out of the blue, I can see Hal's HAP is available to me, and I don't know if it's up and connected to the broader mesh. It's not. But if we had tunnels or other devices, all of a sudden this would populate at home. This is a wall of about 3,000 different services that are currently available. I don't know who joined the mesh recently, but it went from 600 to about 3,000 from the last time I looked. So, oh yeah, this is not me magically. You saw we plugged it in, Ethernet kicked on, and it worked. If I had this one, and we had internet, I would be able to hit the tunnel back to home, and then from there to the broader mesh and anything that's accessible.
You can use that. For those of you who are not real familiar with networking, there's a lot about this that gives you the ability to do it even if you don't know stuff. For those of you who are in IT, if you don't go through the steps, you're going to be sorry, because a lot of it is unique, and you got to take your time and go through the steps, or you're going to mess up. So both sides. It's got training wheels, but it's got a lot of trippers for people who don't pay attention. Do you have something to say? I would love to hear from you. Okay.
There's a little bit of fanboy moments going over here. But yeah, it isn't something to be scared of. It is not. You're not going to be spending configuring IP stacks or anything like that. It literally, once it's configured, plug in, mesh there, broader mesh available, and now it's just like, all right, cool. If this was booted, it's like, let me plug in my phone, let me plug in my camera, or let me plug in my antenna. This comes up on its own. Plug in my laptop, plug in the PoE, plug in power, and now I have a complete relay node available to me to just run and be available, and we can deploy these and set them out, and they're I don't have to deploy them. I can send anyone else out to set them up and just, hey, here's the step guide of putting this online.